Welcome to the summary of the DFIA August 2025 meeting, focusing on probability theory and optimization. This video outlines the key discussions, calculations, and strategic conclusions from the session. The meeting utilized case studies and complex spreadsheet functions to optimize supplier selection and refine forecasting strategy. The core of the discussion was applying probability theory to make optimized inventory decisions. The session started with a 7-week case study to calculate closing inventory and initial stockout probability. The initial unconditional stockout probability was found to be approximately 72%, which was considered too high for optimization without knowing the root causes. The concept of conditional probability was introduced, using supplier performance as a condition to refine the stockout risk. This allowed the team to measure risk based on specific supplier delays. Calculating the conditional stockout probability per supplier showed a range of performance: S1 at 67%, S2 at 100%, and S3 at 50%. Based on this analysis, supplier S3 was confirmed as the optimized decision for the week 8 order, presenting the minimum stockout risk at 50%. The discussion then pivoted to challenges in forecasting strategy. A key challenge addressed was reconciling daily order tracking with monthly forecasts, often split into equal weekly buckets. The recommended approach is a reverse forecasting strategy. Start with day-wise forecasts, then aggregate to week-wise, and finally to month-wise for improved accuracy. The team moved on to a practical exercise using complex conditional probability. This exercise involved using complex spreadsheet functions like SUMPRODUCT and COUNTIFS to calculate conditional stockout probability based on multiple causes. The analysis focused on two main causes of stockouts: lead time exceeding 15 days and forecast error being over 30%. The final part involved identifying high-risk scenarios and prescribing immediate actions. Analysis of combined causes revealed SKUs 2, 3, and 5 to be in a high-risk zone, with a 75% stockout probability when both lead time and forecast error conditions were met. The optimization strategy is clear. Immediate action is required to control lead time for SKUs 1, 2, and 5, and reduce forecast error to less than 30% for SKUs 3 and 5. In conclusion, conditional probability provided the necessary insight for optimized decision-making. The team agreed on the need to review the complex formulas for future application, and the session concluded with a follow-up action to share the Stockout optimization conditional probability file.